So let's go over implicit differentiation. And why do they call it implicit? Well, an explicit equation is when a variable is isolated. Implicit equation is when the variables are mixed on each side. So also let's look at this notation d dx. We would read it as the derivative with respect to x. And then you can have d dx of whatever thing. So here we have d dx of y. It means the derivative of y with respect to x. And let's compare the chain rule to implicit differentiation. If we wanted to find the derivative with respect to x of this function, we would use the chain rule because we have an outside and an inside, and we can do the derivative of the outside, leaving the inside the same, and this is still the derivative of the outside here, times the derivative of the inside. And the same concept is used for implicit differentiation. We have y being an inside function of x. We don't know what that function is. So this is easier than this because we just have less to do. So we have the outside is cubed and the inside is some function of x that we don't know. So to take the derivative with respect to x, we'll do the chain rule. We do the derivative of the outside, that's multiplied by 3, and then subtract 1, leaving the inside the same, and then times the derivative of the inside. So that's why we put the dy dx on there in that situation. So if we're taking the derivative of x with respect to x, that's how we normally find derivatives, how we've been finding derivatives. So the derivative of x squared is 2x. The derivative of y squared is 2y dy dx, because that's the chain rule. And now we want to get dy dx by itself. Subtract 2x. Divide by negative 2y, x or y. Okay, pause the video and try that one. Derivative of x cubed, and the derivative of y cubed. When we do the derivative of y, we need the dy dx. Let's isolate dy dx. And then we have to be careful of all the other derivative rules like product and quotient. So if we find the derivative of this, we have to see that there are two products. So we have to use the product rule twice, and let's set that up. So that's the first product rule for that. Then we need a product rule for that. And we'll have the derivative of negative 2 is 0. So the first product rule, we have the first factor times the derivative of the second factor, dy dx. Because if we do the power rule, we just get 1, and then the derivative of y is dy dx. Then we have the second factor times the derivative of the first factor. We're done with that product rule. Now we'll do this product rule, the first factor times the derivative of the second factor, and then we'll go the second factor times the derivative of the first factor. We need the dy dx. Now we need to isolate dy dx, so we're going to leave this on the left, leave that on the left, and we'll subtract these. And we'll put this, we'll leave it over here. And then we'll subtract this, so 2xy, and subtract that. Okay, let's factor out a dy dx. And then divide to isolate dy dx. Okay, pause the video and try this one. Watch for, find out where the product is. So we do have a product there, so we have to do a product rule. I'll just leave the 2 with the sign, and that'll be the first factor, and cosine will be the second factor. So we just have one product rule. The derivative of 1 is 0, and then we'll have the first factor times the derivative of the second factor. That is negative sine y, but there's a y there, so we have to put dy dx. Then we have the second factor times the derivative of the first, and that's going to be 2 cosine x. All right, isolate dy dx, so we'll subtract this, and over here we have negative 2 sine x sine y dy dx, and we'll have negative 2 cosine x cosine y. Subtract that, we'll get that. So dy dx is divided by that. And we could rewrite it with cotangent, but I'll just leave it like that. Okay, let's use implicit differentiation to find the equation of a tangent line. Whenever we want the equation of a tangent line, we have to find the slope and then do point slope. So the slope is using the derivative. Let's find the derivative of this. We can use the chain rule for that. So the derivative of the outside, leaving the inside the same, times the derivative of the inside. Then we're going to do the derivative of this, 2, y minus 2. Then we have to do the derivative of the inside, which is dy dx. And the derivative of 20. Let's get dy dx by itself, so we're going to subtract that. We have this left over. Subtract that. And divide. Divide by that. Cancel. And substitute. So we want to evaluate dy dx, evaluate it at 3, 4. So we put a 3 in for the x, 4 in for y, and we end up with negative 4 over 2, so negative 2. And then point slope, we just do y minus y equals m. The slope x minus x. So add 4. Okay, pause the video and try that one. We need to find the slope, and then do point slope. Here we have a product, so it's going to be the first times the derivative of the second plus the second times the derivative of the first, and we have the derivative of that is 4x. So the first times the derivative of this is going to be 2x plus 2y dy dx, and then we have the second factor times the derivative of the first, 2y dy dx. We need to distribute that just so we can separate the dy dx. So I'm going to distribute that. We have 2xy squared. We're going to go like that. Then we have 2y cubed, and that was like that. Now let's take this times that. We have 2x squared y dy dx, and 2y cubed dy dx. Looks like I didn't have to do that step, but it's okay. Now we have dy dx, and we can just subtract that because it doesn't have a dy dx, subtract it to that side. At the same time, let's factor dy dx out of all of these. So we have 4x minus this, and then I'll rewrite this with the dy dx out in front, and then everything else just copied. And we have 2y cubed, so that'll be a 4y cubed, 2x squared y. Alright, so I just divided both sides by that, and now we evaluated at 1, 1. Evaluated at 1, 1. 4 times 1 minus 2 times 1 squared. Putting the x values in and the y values in. 2 times 1 squared times 1. 4 minus 2, 4 plus 2, 1/3. We have the slope. And point slope will be y minus y equals m x minus x. So we have the x value and the y value and the slope. This is 3 over 3, so I'm going to add 3 over 3, and that means we'll get 2 over 3. Okay, there's just one more thing we have to do that's has a little extra step in it, and that's finding the second derivative. So that's how we write the second derivative. There's a 2 on the d and then 2 on the x. So let's start by finding the first derivative. 3y squared dy dx, 2x, 4. Isolate the dy dx, and we're going to subtract 2x and divide by 3y squared. That's the first derivative. And now we do the derivative of this. It's a quotient, so we need the quotient rule. And we have the denominator times the derivative of the numerator. The numerator times the derivative of the denominator. And the denominator squared. Then we don't want this dy dx there, so we'll substitute this right here. We can simplify. We get negative 6y squared. And over here we can have and then dy dx. That should be 9y to the 4th. So if we square that, 9y to the 4th. Okay, we have all of this with this denominator. Let's get the same denominator over here. Oh, before we do that, we have a 6y and a 3y squared. Well, that can reduce, so we have a smaller denominator. We also have 4 minus 2x, 4 minus 2x, so that can be combined. Negative 6y squared minus 4 minus 2x squared, because we have two factors. And we're going to have a 6 divided by 3 is 2. And then y cancels with y, and we'll have just one y in the denominator. And let's get a common denominator. So multiply by y over y. So now we have negative 6y cubed minus 4 minus 2x squared, and that's all over y. And then the y can just be written down here as a y to the 5th. All right, pause the video and try that one. Start with the first derivative. Isolate dy dx. Now find the second derivative. And we could rewrite this with a negative exponent and use the power rule, but I think there might be some confusion about where the dy dx goes. So let's just use the quotient rule. Denominator times the derivative of the numerator. Numerator times the derivative of the denominator, and the denominator squared. So that's negative dy dx. This is 0. Let's substitute for dy dx. That's 1 over y. So negative 1 over y and we can rewrite that as negative 1 over y cubed. And we'll stop there.